Two girls are playing seesaw. Is it like the chemistry structure, cis structure, trans structure? Then this is our left hand and then right hand. There is a mirror, so it like mirror image. But it cannot be superimposable. Okay, look like the girl. The girl, we call it, is it the same? Like reflection, right? We call it as enantiomer if we learn in chemistry. So what is enantiomer? Our hand. This is the chemistry structure. So today we are going to learn stereoisomerism.
For this video, we are going to look at the second part of isomerism, which is stereoisomerism. So for stereoisomerism, there are two parts, diastereomer and enantiomer. So for diastereomer, we are focused on cis-trans isomer. The other name for cis-trans isomer is geometrical isomerism.
What is stereoisomerism? Isomer with the same molecular formula but different arrangement of atoms in space. So for this one, we more on three-dimensional viewer. First, diastereomer is non-mirror image. We can call it as cis-trans isomer or geometrical isomer as well. The second one is enantiomer, is mirror image, or we call it as optical isomerism. So what is cis-trans, geometrical, or diastereomer isomer? Differ by group being on the same side, cis isomer. Opposite side, we call it as trans isomer of a side of rigidity in a molecule. How rigid is it? Let's check. So the requirements for geometrical isomerism, first, restricted rotation about carbon-carbon double bond in alkene, C double bond C, or a carbon-carbon single bond in a cyclic compound. This is the rigid of geometrical isomer, mass carbon-carbon double bond or carbon-carbon single bond in cyclic compound. The second requirement is each carbon atom of a side of restricted rotation has two different groups attached to it. Meaning that the carbon-carbon cyclic compound or carbon-carbon double bond compound, right, must attach with two different atoms or two different groups. So you must fulfill these two requirements, then only can consider as geometrical isomer. So let's look at the example. So cis isomer. Why is cis isomer? Because having the same atom or same molecule or same group at the same side. And then this one different side, that's why it's trans isomer. If we know the name of the structure, we give the exact name, cis 2-butane, and then this one is trans 2-butane. So this is carbon-carbon double bond alkene, and then this one is carbon-carbon single bond cyclic compound. So with the same side, that's why it's cis isomer. This is cis-1,2-dimethyl cyclohexane. If the group with different side, okay, this is trans-1,2-dimethyl cyclohexane. If one of the doubly bonded carbon has two identical groups, geometrical isomerism is not possible. Let's look at this example. Yes, with carbon-carbon double bond, fulfill the first requirement. But the second requirement must attach with two different groups. But for this compound, it's the same. Hydrogen is the same. That's why this is not cis-trans isomer. Please take note. Next, cis-trans isomer has similar chemical properties but different physical properties. They are different in melting and boiling point and solubility due to the different polarity of the molecule. So for cis isomer is polar molecule, but for trans isomer is non-polar because it can cancel off. The dipole moment of the trans isomer can be cancelled off. That's why this is non-polar molecule. And then we have to know melting point for trans isomer is higher compared to cis. Boiling point for cis isomer is higher compared to trans. And then the stability of trans isomer is more stable compared to cis isomer. Why?
For this slide, we are going to discuss comparison of melting point and boiling point for cis and trans isomerism. So this one we focus on boiling point. What is boiling point? It's from liquid change to gas. Cis isomer has higher boiling point because it is a polar molecule, while trans isomer is non-polar molecule. If you still remember, cis isomer polar meaning that it has stronger van der Waals forces, which is dipole-dipole forces, compared to non-polar, which is London dispersion forces. Okay, dipole-dipole forces is stronger than London dispersion forces. Okay, so we check. Okay, this is the cis isomer. The dipole moment cannot cancel off each other. Okay, that's why there is a resultant dipole moment downwards. So mu not equal to 0 polar, cis isomer. But for trans, yes, left, here cancel off, here and here cancel off. That's why mu equal to 0, non-polar. Trans 1,2 dichloroethane.
Next is about melting point. Melting point is solid change to liquid. Trans isomer has higher melting point because the molecules are more closely packed in solid lattice. Why? If you look at this trans 1,2 dichloroethane structure, this is the heavy part, this one is light. And then this part is light, this one is heavy. So the combination between heavy and light, right? So make the molecule closely packed. It's more difficult to break. That's why melting point higher. Let's proceed with next topic, enantiomer.
First, enantiomer or optical isomerism, we must know, is the process of a beam of light is passed through of a piece of polarizer prism. The emergent light vibrates in a single plane, hence it is called a plane polarized light. Later it will show by diagram, then you understand what happened. Optically active compounds have the ability to rotate plane polarized light. Angle of rotation is measured with an instrument called polarimeter. What we explained just now is showing by this diagram. So this is polarimeter, so containing an optically active sample. So first, this is the source of light, and then pass through the unpolarized and polarized prism, and then this is the sample tube. Then the light emergent vibrate in a single plane, so this over here, and then this we call as plane polarized light. So it has the ability to rotate, can be rotate in clockwise or anti-clockwise. If clockwise, we use positive sign, and then anti-clockwise is minus negative sign. Okay, the name of the positive plus sign, we call it dextrorotatory, and then the negative sign, we call it as levorotatory. Okay, normally exam would ask this kind of question, but just for your knowledge. After that, variable analyzing prints is here. Okay, and then you can watch through the eye pieces. Next, the requirements for enantiomer. First, molecule contain a chiral carbon, chirality center, or stereogenic center. Actually, chiral carbon, chirality center, stereogenic center is the same thing, just different name. And then what is chiral carbon? Means a sp3 hybridized carbon atom with 4 different atoms or 4 different groups attached to it. So remember, what is sp3 hybridized carbon? Means the carbon must have 4 single bond, and the 4 single bond must attach with 4 different atoms or groups. The second requirement is molecule is not superimposable with its mirror image. What is superimposable? What is mirror image? Let's check. You see? This is mirror image, something like reflection, okay? And then this is mirror image as well, mirror image as well. But this mirror image not superimposable, meaning that when I take this E, put on the top over here, so it should be like this, okay? So it cannot be superimposable, okay? Or if you try to take out your hand, okay, put on the same side. You try to attach your hand, put on the same side. So it cannot be super impossible. Okay.
So look at this example, a chiral carbon molecule. So this carbon with sp3 hybridized and then with four different atoms, p, s, r, q. So this called as chiral carbon. Make sure that the four atom or the four group is different attached to the sp3 carbon. Okay, so for example, this carbon with bromine atom, hydroxyl group, hydrogen atom, and chlorine atom. We are using this R strict, right, to designate chiral carbon or chiral center. Okay, let's look at others example of chiral carbon. We are going to check one by one. For this carbon, cannot be chiral carbon because H3, 3 atom is the same. How about this carbon? Yes, attached to CH3, attached to chlorine, attached to hydrogen, and then attached to CH3, CH2, CH3. So attached to 4 different group or atom. Yes, for the carbon, number 2 is the chiral carbon. How about this one? Okay, for this cyclopentane, impossible because with 2 hydrogen, 2 hydrogen, 2 hydrogen, and 2 hydrogen cannot with the same type or same atom. Same group cannot. How about this one? Yes. This carbon attached with a cyclopentane, attached with bromine, attached with 1 hydrogen, and attached with 1 CH3 methyl group. Yes, this is chiral carbon. For this carbon cannot because with 3 at hydrogen atom. So same atom cannot be chiral carbon. This one we check. Okay, CH3 impossible. This C, yes, with hydroxyl group, with CH3 group, with hydrogen atom, and then with COOH, yes. And then this one, this C with C double bond O, C double bond cannot be. It's not a sp3 carbon. Cannot assign as chiral carbon. For this one, CH3 cannot. For this C with CH3 group, hydroxyl group, hydrogen atom, and with this big group. So yes, this is chiral carbon. And then for this one, hydrogen, CH3, CH3, both, okay, attached with 2 same groups, CH3, 2 methyl group, cannot be chiral carbon. Same for this carbon with 3 hydrogen, so cannot be chiral carbon. So I think with these few examples, right, you clear what is chiral carbon. So try this practice 6. Label the chiral carbon by using the symbol of R strict. Try it by yourself first. Yes, this is the answer. Only this carbon and this carbon with the chiral center or stereogenic center.
Molecule is not super impossible with its mirror image. Look at this 2-butanol example. So this carbon is a sp3 hybridized carbon with 4 different groups, CH3, OH, hydrogen, and CH2, CH3. When we draw the enantiomer, right, we must draw in 3-dimensional formula. So, okay, if you still remember, right, this 3-dimensional formula we learned in 4.1, okay, the first video. So remember the dash is point out, and then the black color, the black dash is point in. So you have to draw a mirror over here and then reflect it, CH2, CH3, and then here hydrogen, hydrogen, OH, OH. Reflect like this. Okay, it's up to you, both acceptable. Okay, and then CH3. No matter this or that one also can, as long as mirror image. Okay, don't forget must label enantiomer. Without label, 1 mark will be lost. Okay, this one, whether want to show it cannot be super impossible. Because what means by super impossible? Original is like this, right? Okay, when you put like this, they are not super impossible. In Malay term is tak pertinde. Okay, look at another example. So CH3 one group, OH one group, hydrogen one group, COH another one group. So sp3 carbon. So this carbon is chiral carbon through hydroxypropanoid. So draw the enantiomer like this, draw a mirror and then reflect. So make sure make the put the asterisk symbol for the carbon, for the chiral carbon. Okay. Okay. Ensure that while you draw the structural formula like this, right? Okay, you must tally with your structure. So for example, here is CH3 followed by OH, and then followed by H and COOH. So the message that I want to deliver here, right? Okay, if you are putting A over here and then followed by B and then C and then D. So while you draw the enantiomer, right? Okay, you must follow the A, B, C, D sequence. So meaning that here is A and then here is B, here is C, here is D. Okay, you have to follow the sequence. You cannot hear A, B, C, D, and then suddenly you draw A over here, and then here is the C, and then here is the B. Cannot. So then your enantiomer will be wrong. Okay, make sure you follow the sequence. If you show the bonding of the molecular formula or structural formula, if molecular formula doesn't matter, but when you show the structural formula, yes, you have to follow the sequence according to your structural formula. Okay, the last topic of this video is racemic or racemic mixture. It's an equimolar mixture of enantiomer which is optically inactive. Why optically inactive? Because the two components rotate plane polarized light equally, meaning that they have the same degree of rotation but in opposite direction, so they can cancel off each other's rotation. Then a pair of enantiomer have similar chemicals and physical properties, but different in the direction of rotation of plane polarized light, meaning that one is follow clockwise, another one is anti-clockwise. This slide is about the daily life application for chiral carbon compound. So treatment of Parkinson disease, toxic to human. You see different rotation, right? Clockwise and anti-clockwise, different rotation. There are different function. Okay, just extra information.